The other challenges were more technical in terms of running a multi-user facility, because what you want is for the end of the cryo nozzle, so we'll take the Oxford Cryostream because that's where we are, that has an 8mm, or the 500 series, which was the first one, had an 8mm diameter of coldness, and then there was a very fast ramp up to room temperature across about 2mm. So you've got a temperature profile that goes from room temperature down and then up again. So you want the crystal to be completely immersed in that stream. But lining that up was very, very difficult at first, because the Cryostream had a stand which required an Allen key to adjust it. So you would undo the Allen bolt, the whole thing would move, and then you couldn't get it back to where you wanted. And then when you did it up, you'd move it because you're rotating it clockwise. So I begged John Cozier and Mike Glazer to make a stand with adjustable translations on, both upwards, downwards, that way, and that way, and that way. So three-dimensional. So that was, they did, and made a beautiful device which saved us hours of messing around lining up. But the second thing was that it was still quite hard to get the nozzle pointing at exactly where the crystal would be. So I made a little nozzle, which this one's made of brass, and the first one I made on my husband's lathe at home had no holes in it, because we always lined up the Cryostream when it was warm, and then we would line it up, put this little point where the camera, where you lined the crystal up, so instead of the crystal you'd have this little point, so you'd know it was pointing there. This was about the right distance, if you put this right on the nozzle, away from the crystal, so that you didn't want the Cryostream shadowing the detector, so it had to be close enough but not too close. And then there was one dreadful day when the experimenter came and said they'd forgotten to line up the Cryostream, and it was cold already, and we screwed this on, and it shrank because it was brass, and the nozzle of the Cryostream is stainless steel, and it cold welded onto the end of the Cryostream. We couldn't get it off, so we lined it up. We had to warm up the Cryostream to get this off, and at that point I said, right, this one's not good enough, it needs holes in it, so the hole, but it was still very klutzy. So I went down to the workshop in LMB. We had a wonderful workshop technician, a man by the two mics, and they made me another one which was stainless steel, which with holes in, and it was much lighter. But then I showed it to Mike and John, and the Oxford Cryosystems started to make these, and they were the first device makers, cryostat makers, that actually provided something for lining up. And this is the one that now goes out with every Cryostream. So I'm very proud of that. We published it in a little Journal of Applied Crystallography paper in 1994 with my a student I was working with, a student of Louise Johnson's called Ed Mitchell, who's now the industrial manager of the ESRF in Grenoble. So I did this with him, and yeah. So
very nice. Thank you very much for this contribution as well.
Well, there were a lot of other gizmos too, but we can get onto them maybe. This is the one that's the longest lasting, and you're still providing with the Cryostream.